So I'm going to present some work that it is in around the same area, but mainly has mostly industrial and applicability focus. So I hope I won't disappoint you, because it is mainly from the usage from another point of view. This is a set of papers, but I'm going to emphasize on the first one, which is the one that was the best one and the work that is being continued. And I am in a very difficult position to present work that was published before and not being able to present more later work because it's under submission. So I will discuss about the classification algorithms framework, and as you can see, publication 2 and 3 are commented out. It's because I was recently writing some code, so I commented them out. That doesn't mean I won't discuss about them, it will just be less focused. And on the part 2, I'm going to discuss about how we evaluate DSLs in general, how we evaluated DSLs in that particular instance, and how we evaluate DSLs in general. And in the end, I have some open issues to discuss about potential collaboration within networking group for MD or any group that has similar interests. This work happened, that was funded much originally by BT Research at Industrial Park, and the other co-authors, Detlef Nauk, was from the AI side of BT. So, and from Bournemouth University, we had the software engineering side. There were some much funded students, but not on this work. This work was one much funded student that stopped, which I continued because the subject is quite hard for students to work on. And the main element is the work about the attempt to go towards AI adoption and to consider AI in contents. We don't go inside the adaptivity, so we don't go inside to create algorithms to provide adaptivity either at a runtime or anything else, but we offer the backbone which will help to add this AI within bigger contexts and can be extended with more algorithms in the future. So our focus is mainly on interoperability and interfacing, and I'll explain what I mean by that. To give you just a quick overview of the team's background is on SysML. I started off on SysML, but then, and I'm still teaching SysML at the university, but the domain-specific languages is something that won over my heart. So I've been working on it with JetBrains for the last 3 or 4 years. And this is the publication. This DSL is quite, it's not a simple DSL. It has a very simple interface. It has a lot of code underneath it and a very good generator. And believe me, there is a lot of technical complexity behind it. And its original target was to help data scientists to be more efficient in their work. However, it had more success with non-data scientist domain users, and that is something that can be discussed. This is the output of the results in the screen. So it's quite simple. We have a couple of pages. And it's actually, you don't have a couple of pages, you have one page. It's a couple of screenshots I've taken. So everything is in one page, and you just upload the files and change in order to use different algorithms and different input and output. We have worked in the meantime since this was published, and this to improve this interface, not to make it more than one page, because the one page interface was the positive the most positive aspect of the feedback, but we have made things like to be able to upload the location of the files with a browsing button and some shrink work so that is better. So the important characteristic is that everything is in one page. We really think that a lot of other tools to provide to help the AI process contain many pages and a lot of confusion without any particular reason. And the user only needs to know where the input and the output should go and to be able to press a button. So, however, although that appears very easy, a domain user that doesn't know computing and doesn't know AI at all might still find problems. So the interface of this needs extensions and work. And again, my main conclusion is that this language had more success and there is more potential to discuss about democratizing this AI into non-technical users. A lot of things can be done in that in many areas. This work was the backbone so that many other things can be added. Then there is a couple of other publications, which I won't go into them into any detail. I can discuss for whoever is interested. This one is the last one, which is called Adaptive Systems. And the Adaptive Systems one is actually the Adaptive Systems one is actually the target one. The Adaptive VLE was an intermediate publication where we published the status of the work. And the adaptive system is the way of using the language composition by MPS in order to call many different, in order to call many elements and to actually implement the map-AK loop without actually going into any particular algorithms for its efficiency. So it is quite simple, but its main purpose is to provide the structure, and its main purpose and the future direction that we see is how this can be invoked by other applications and by web services, for example, which is one of the themes that is part of future work. So we used the MPS DSL composability of languages, which is a very powerful feature. And we developed a set of languages that you can use in order to implement that. Many extensions can happen, but that depends on future collaborations and funding, as you can understand. One direction is to add adaptivity patterns or algorithms. Another direction is to go into formality. So use some constraints, for example, to initiate formal methods or use languages that are already connected with formal methods, and that would give verified AI, for example, and to port into other application domains. The second part that I wanted to raise for discussion is how we evaluated the DSL. We evaluated that particular DSL following work from a professor in Izmir University, if I'm not mistaken, where they had created some quality metrics where you did a questionnaire and give it to the users and get the feedback. That method was good up to a point. It had some drawbacks, like how objective or standardized the questions are. For example, we ask questions, we create the questionnaires and we ask questions to evaluate the DSL, but it's not always objective what we are actually asking, because we are biased, especially if we are the ones that develop the language. So that is another possible future direction, and that is actually something I was meant to put it as a discussion in any networks that would be interesting in this. This is a general slide about future directions of this work. There are many, and they can be diverse as well. One is the quality metrics. There is a requirement for formal aspects in any AI system you create. The usability aspects is that something we are already addressing, but it's probably not a full proper usability study that needs to happen. More AI capabilities and more domains. And the last but not least is how you integrate the DSLs in the web, and how an organization and a software company, for example, or any company that has existing systems can integrate the DSLs in their environment. This is the idea about the some of the ideas about collaboration within groups in the area of quality and metrics, because that is something I have, to my knowledge, I haven't seen anything standardized by anyone yet. Also, there is the theme of why and how we can apply DSLs, which hasn't been formalized more than some papers by some informal writing by Markus Voigtler. And the last one is about a discussion about how you use models in an integrated way, which is probably towards the modelic direction.